All right, let's go ahead and get started. So this time, the distance learning that I'm going to be focusing on today, or on this section, is the Kimi and Jordan assignment. So this is the one that has you, basically there's two people, Kimi and Jordan, that are each working during the summer. They both get an allowance, and you're basically making a table to represent how much money they would make over hours, and then you turn those tables into equations. Then we sketch the graph, and then at the end we kind of answer some information about how much money they're going to save in the week if they work the same number of hours. So pretty standard question. We actually did quite a few of these back when we covered linear functions, when we did systems. It's just been a little while. So as I mentioned before, I'm not going to be solving the actual questions that you get. Okay, so what I did is I went in and I changed the values of how much they make an hour and what their allowances are, and we're going to solve a problem that's slightly different. Okay, so I'm going to switch to that problem right now. Okay, so my problem, instead of Kimi and Jordan, we're going to do Kim and Jordana. Kim and Jordana are each working during the summer to earn money in addition to their weekly allowance, and they are saving all their money. Kim earns $10.50 an hour at her job, and her allowance is $11 per week. Jordana earns $9.50 an hour, and her allowance is $15 per week. Okay, so the first thing we need to do, and this is part A, has us filling out a table where we fill in the information for how much money they would have after a certain number of hours. Okay, and so the key one, and one of the things that's really key to this whole idea is, so first of all, I want to isolate, I'm only looking at Kim right now. Okay, so I'm going to highlight only Kim's information. Okay, so we have all of Jordana's stuff here where she earns $9.50 an hour and $15 per week. We're going to ignore that because right now all I care about is just Kim's information. Okay, those are the only numbers that matter to me at this moment. Okay, and so logically you can probably kind of think through this first element in the table should be really, really easy. Okay, because if I go to my job for 0 hours, I do no work at my actual job. What money do I make? I don't make any from my job. So in Kim's case, the only money she's going to get is what? Well, if we think about that, it's got to be the allowance, right? Because if you don't, no matter if she works or not, it says she gets her allowance of $11 per week, okay? And remember that these tables represent their total savings for a week, okay? She's only going to get that allowance once a week. So if she works 0 hours, she's going to make $11 for that week. Okay, so now we start looking at the case of 1, okay? Well, 1, pretty easy. Okay, if she only works 1 hour, okay, well, every hour at her job, she gets $10.50. So that means I'm going to get $10.50, okay? But I'm also, just because if I work an hour at my job, I don't lose my allowance, right? So I'm going to add 11 to that because she's going to get her allowance and she's going to get the amount of money for working the hour at her job. Okay, so that puts us here at $21.50. Okay. So now, when I move over to 2 hours, what's changing? Okay, which one of these numbers, the 10.50 or the 11, is going to change if she works another hour? Well, the allowance, the 11, has nothing to do with whether she works or not, right? We even gave her the 11 when she worked 0 hours, okay? The thing that's going to change is the 10.50, okay? So the 10.50, instead of just getting 1 hour of 10.50, it's actually going to end up with, move it over real quick, 2 hours at $10.50 an hour, and then plus our allowance of 11. Okay, so if we work that out, that comes out, the 2 times 10.50 comes out to 21, and the plus 11, sorry about that, I accidentally clicked out of the OneNote page that I'm writing on, so forgive me for that, plus the 11 from her allowance, right? So when we add those two together, that means if she works 2 hours, she's got $32. Okay? And you can kind of figure out what you're going to do as you continue on through this, right? Because in the case of the next one, the only thing that's going to be different is instead of multiplying the 10.50 by 2, well, now instead of 2 hours, she's working for 3 hours. So we just multiply the 10.50 times 3, right? And we kind of just work through and fill in the rest of this process. If you want to double check me, I'm going to fill in the answers right now. If you want to double check me as you go, you're welcome to. Okay, so this one is going to be 42.50. Okay, this next one is going to be 53. Next one is 63.50. And this one will be 74. And then finally 84.50. Awesome. Okay, so now with Jordana, we have a pretty similar calculation we need to make. Okay, so now though, the only difference again is that instead of looking at Kim's numbers, we're going to be looking at Jordana's numbers. Okay, so some things changed this time, right? Same basic process. Okay, so if Jordana works 0 hours, well, she earns $9.50 an hour and she gets $15 per week. Okay, so if she doesn't work at her job, she won't get any of the $9.50s. Okay, but she will still get the $15. Okay, so that's her base starting value. Okay, and then we're just going to add 950, so basically do the exact same process we did where it's 950 plus the 15 because the 950 is being multiplied by 1, right? And 1 times 950 is just going to be 950. Okay, so that means this comes out to 24.50. Okay, and then if we kind of follow that exact same process, we're going to work through. The next one will be 35. The next one, oh, sorry, no, not 35. 34. Okay, and then after that, we will be looking at 43.50. Carrying on. Okay, and again, all of these I'm just doing 950 times the number of hours plus the allowance. Okay. Continuing forward, this one is going to be 53. This one is going to be 62.50. Next one is 72. Next one after that would be 81.50. Okay, and there we go. Okay, so that leaves us with the answer for part A, or at least the process for how to do part A. Now again, remember, my table is using different numbers than what your guys' problem is doing. So modify the process that I'm giving you to try to apply that to your problem if you've been having trouble. Okay? So let's go ahead and look at 2B and 2C. Okay? Now these ones are going to be very connected to that process that we were just doing, right? So remember, let's say I wanted to do like the next step in the table, right? So we always did so let's just take Kim, because Kim is the one we're doing in B here. Okay, so we have 10.50 an hour. So we did 10.50 times, like, let's say 3 hours, right? Let's say if we work 3 hours at her job, and then she also makes that $11 in allowance. Okay, well, what if instead of being 3 hours, what if the number of hours was H? What if it was unknown, right? Well, I wouldn't need the parentheses, first of all. Okay, so basically, if you go back and think about what we did in that process, we always did the number of hours the dollars she makes per hour times the number of hours plus her allowance. Okay, and that's going to represent the equation, because then all I would need to do to use this equation to figure out how much money she made is just plug in a value for H. Okay, so the one thing I'm missing here is I do need to basically make it equal to some variable. Okay, and because this one is Kimi, okay, I'm going to just make it equal to K, because that's what the table said to make it equal to. Okay, now from here you can probably figure out what Jordana's equation is going to be. It's going to be very similar. We're going to have a J instead of a K, obviously, because it's a different person. Okay, so we need a different variable. The hours part is okay to be the same variable because it's the number of hours. It doesn't change really between whether it's Kimi or Jordana, but the amount of money they save is going to matter. Okay, so we're going to have J equals, now next to the number of hours, remember we put how much she makes an hour. Okay, so for Jordana, that's $9.50 an hour. So $9.50 H plus the allowance, which is 15. Okay, so from there we've made our two equations for B and C. Okay, so now let's take a look at D. Okay, so D has us making a graph. Okay, now when I go back and look at my table, these values are pretty large, right? We need to go all the way up to in the 80s, okay, and we're as low as around the 10s, right? 11 and 15. Okay, so if I want to put these graphs together, I want to make sure I include numbers that go pretty high, okay? And one of the key things is this one says to sketch the graph, okay? So there's going to be a little bit of estimation here. We need to do our best to kind of make this work, okay? So remember, when we graph lines, okay, we always start with the b value. Remember, this is y equals mx plus b form. This is in slope-intercept form. So even though this is a different variable, it doesn't say y, it's still a variable. It's still in that same form of y equals mx plus b. That's a really ugly plus sign. Let's try that again. Okay, so that means that my b is 11 and my m is 1050. Okay, or in other words, remember the m is the slope. Okay, so we're going to put that as 1050 over 1, because remember, I need to make it into a fraction. Remember, slope is rise over run. So 1050 is my rise, how much I'm going to go up, and the 1 is my run, how much I'm going to go to the side. Okay, so remember, our first point is always the y-intercept, okay, our outside number. So in this case, that is positive 11. So I'm going to go to my y-axis, because it's the y-intercept, and I'm going to find roughly where 11 is. Now again, remember, this is a sketch. It's not going to be perfect, okay? But I know that 11 should be just a little bit above 10, so that looks like it's about in the right spot. So each of my lines is basically counting by 5, okay? So 11 is going to be just a hair above 10. Okay, so now when I start doing my other ones, I can use the tables that I made on the last one to kind of help me sketch these. So I know the next one should be on 2150, okay? So when I go over to 1 hour, I should go up to about 2150. So again, just a little bit above the 20. Okay. If I go back to my table again, the next one at 2 hours should be $32. Okay. So 2 hours, go up to 32. Now this one should be a little higher because 35 is right here. So I'm going to put it kind of close to the middle. It's not going to be quite in the middle. It's going to be a little below that technically. Okay. Because it's 32. But it should be somewhere right around there. And again, this is a sketch, so we're just trying to get as close as we can, okay? So let's go ahead and keep going back, all right? So for the next one, we have 3 at 4250. So 3 at 4250. So this one's going to be right in the middle here because 2.5 is halfway between, so 42.5 would be halfway between 40 and 45. Okay, and again, you can already kind of see my line forming here, right? And again, forgive my not so straight line, okay? But we already see a pretty good line going there, okay? And I'm going to continue this for just a little bit more. I'm going to do one more point, so that is number the 4 and 53, okay? And we'll talk about why that point's going to be important here in a second, why I'm saving it for last. Okay, and again, I would just continue this process and just kind of map the line all the way up. I would keep doing the points, but just to kind of speed this process along, you guys don't need to watch me plotting points for the next 20 minutes, okay? So let's do Jordana very similarly really quick. Okay, so the first thing, I'm going to change colors for her just to make it a little more obvious. Okay, let's do her in orange, sure. Okay, so we're going to put our first point at 15. Okay, which is halfway between 10 and 20. Okay, and now I'm going up 9.5. So remember, if I go back to my points here, I can get really exact values. So the first one at 1 hour, she should make about $24.5. So at 1 hour, I'm going to go over to 1 and up to 24.5, which is going to be right below the 25. Okay, and then my next one, oops, sorry, wrong place. Okay, my next one, I'm looking at 2 hours, I'm looking at $34, okay? So 2 hours up to $34, so again, just shy of the 35. Okay, 43.50 at 3 hours, so I go over to 3 hours, up to 43.50, which is again just a little bit above the line that's there. Okay, and these ones are going to be pretty close together. My equations are pretty much overlapping here, but our last one, 453 yet again. Okay, so that one's going to match up exactly with this point that I have for the other line. So this one is not the same line, right? It is just a little above it and then just a little below it. And they're going to spread out as I go farther and farther apart. Okay, they're going to open up away from each other as it continues on. Okay, and so remember, because it's going to matter for our 1 and E, we're going to use this picture to help us demonstrate E. Remember that Jordan is the orange, and that Kim, or Kimi in your guys' problems case, is the purple. Okay, so Jordana's the orange, and Kim is the purple. Okay, so now let's take a look at our last one. And we're going to be coming back to this picture, so keep that in mind. And I will say, just so you guys know, for your actual problems, this graph is pretty close to one that you could use on yours. Counting by 5s is a pretty good way to go up, and counting by every other 1 on the bottom. So if you make your XY match mine, it'll make your sketch easier to do when you happen to sketch that. Okay, please make sure you label your axes though if you're going to do this. Okay, so remember, if you don't label, I kind of just assume you're counting by 1s. So you need to tell me what you're counting by. In this case, we're counting by 10s. Okay, every other 1 is 10. Okay, so for our last question, this is the one where we're deciding who's going to save more money in the week if they work the same amount. Okay, and this is where our picture is going to help us. Okay, so going back here. So for example, in my situation, if I look at 1 hour, okay, well, who made more money if they only worked 1 hour in the week? Okay, so we have Kimi making a little more than, Kim, excuse me, making a little more than $20. Okay, I think it was $21.50 or $21. Okay, Jordana is making just a little more, right? Okay, how about at 2 hours? Again, Jordan's making just a little more, right? At 3, they're really close together, but again, Jordan is just a little higher, okay? But then at 4 hours, that is the crossing point, because that is where the 2 points intersect. If you go back and look at our initial tables, I'm kind of made a point of this with the arrows when we were marking them. 4 and 53 appears in both, right? That is the solution. That is where these two people are making the same amount of money, working the same amount of hours. Okay, so if I go back to my last one and then we look at like 5 hours, well, now it's flipped, because now the orange line is below the purple line. Jordan is making less money at 5 hours than Kim is, because Kim makes more money per hour, but Jordan has a better allowance. Okay, so if you think about it, if they don't work very much, Jordan makes more money, because Jordan has this initial $15 that gives her more money to begin with. Okay, but if Kim can work enough hours, because Kim has this $10.50 and Jordan's only making $9.50, Kim makes an extra $1 for every hour she works over Jordana. Okay, so the more hours she works, the more money she will have than Jordana, and it's going to be pretty small at first, right? Like they're pretty close together for a lot of this, but as the number of hours would continue, like if they were going to work like a 40-hour work week, like a lot of people do, Kim would make way more money than Jordan would. Okay, so that's why graphs like this are valuable to us. Okay, so if I was going to answer E for my problem, I would say something like Kim makes more money if they work for more than 4 hours. Jordana makes more money if they work for less than 4 hours. All right. Well, that wraps up our work for this problem. That was all A, B, C, D, and E. As I said, this one's pretty straightforward. If you just kind of follow my steps here, it should be pretty helpful. Again, use the way that I set up the graph here, because you got to remember, you want to make all the numbers be able to fit on your graph. You need to make sure that your axis accounts for that, right? So when you look at that table, make sure that your graph will be able to fit everything that's in your table, okay? Because you want to make it go up to all your values, okay? But other than that, that'll be it for this question. So I'm going to stop the recording. You guys have good luck with this one.